Bismillahirrahmanirrahim. Assalamualaikum. So we are from 3 Bmma S11. This is focus Bmma 3523 Automotive Electrical and Electronic System. This is for our assignment Obstacle Avoidance System. The system uses ultrasonic sensor to detect and avoid any obstacle. Then the next slide. This is our group picture. So team member roles and responsibilities. So first is me, Muhammad Shafiq bin Abdul Talib. What I have done, I subdivided the task to the team members, discuss about the title of this assignment, and complete and recheck all the reports and slide and send to the Ulearn platform. Then is Muhammad Badrin bin Shamsuhaimi, responsible to fulfilling the task of generating the coding, conduct the circuit diagram, and try to run it. Then is Muhammad Arif Hafnan bin Abdul Wahid. He generate the report using Microsoft Word and check the format of the report. Demonstrate to the team's member how further develop of this project could be accomplished in the future. Then is Muhammad bin Abdul Hamid. He generate the slide using the Canva and lend a hand to the other member to help complete their tasks respectively. Next, we have Arif Afnan.
I will give explanation for this project. The project is designed to build an obstacle avoidance system using ultrasonic sensor for its movement. An Arduino Uno is used to achieve the desired operation. An ultrasonic sensor detects any obstacle ahead of it and sends a command to the Arduino. The HC SR04 ultrasonic sensor can evaluate distance from 1 cm up to 4 meter used in this project. Function by recording the time it takes the sensor to transmit and receive ultrasonic beams after they have impacted the surface. The ultrasonic sensor is small and powerful in terms of size and performance. It consists of 4-pin VCC pin to offer a 5-volt supply to the sensor, a trigger pin to give a TTL pulse 15 milliseconds, and echo pin to get the output from the sensor, and a ground pin. Next. Then I will explain how the ultrasonic sensor works. To start the sensor and make the measurement, a brief pulse of 10 µS must be applied to the trigger input. The emitter will send an 8-cycle burst of ultrasound at 40 kHz. Increase the echo line. The HC-SR04 wait for the echo and lower the echo line as soon as the signal is detected. As a result, the echo line is an impulse whose width proportionate to the object's distance. The pulse time can be used to calculate the measurement. The signal then hit the surface and return, captured by receiver echo pin of HCSR04, as you can see in the figure on left. Next. We have underlined a 4 problem statement. But first, the obstacle avoidance system ensures the safety of the part that the system was applied as well as the impediment in its environment. A mobile robot that does not have the ability to avoid obstacle will be hazardous for the obstacle as well as the mobile robot. There will be an error when performing the coding and run the system. The third one, the simulation of an obstacle avoiding mobile robot to prevent collision is dependent on the heading of the X and Y axis, the position in the time domain, and the detection of obstacle around the X axis and the Y axis. Last but not least, the angle of heading must be determined in the time domain for the information to be useful for obstacle avoidance. Several equations or relations need to be developed. Next. Mak Badri.
Next, we move to obstacle avoidance system methodology. Following the methodology flowchart, we actually start the process of designing the system by discussing it between us. We go through the internet source, make a research, and try to select the most quality item to place in our system. At the end of the discussion, we finalize the item and we need and list it in our cart. After that, we also decide to use Tinkercad software as our platform to design and run programming simultaneously. Then we design the circuit while referring on the internet and the lecture note that we have learned in the class. By connecting the only significant input and output, we finally get our final design of our circuit. In addition, we also running our microcontroller programming coding at the Tinkercad. After solving all the problems during this process, we finally can run the system without any error. If there is any mistake in our program with the system test, we need to go back to the circuit build up. An overall checkup needs to be analyzed. If the situation occur, the checkup consists of the connection status, whether there is a circuit lost connection or false connection. Also checking the coding format if there is any mistake between the line, and checking each of the component to make sure the component is working perfectly. At last, we managed to get the quality result from the system. Okay, next, Muhammad. For the schematic diagram, this system are using Arduino Uno R3 as a microcontroller board to generate the circuit. One ultrasonic distance sensor is used to sense the motion of obstacle. 4 DC motor are used to make this prototype function, like real and H-bridge motor driver is used to connect the DC motor, the main circuit. This prototype system powered by 9 voltage battery to generate the electric, 250 kilo ohm potentiometer and 1 kilo ohm resistor in the circuit. The display is using LCD 16x2 to pop out the notification to the user. As we can see, at the left is the schematic diagram of the circuit. And at the table, it shows the name and the quantity, also the component that used for this project. Okay, next, Muhammad.
Okay, obstacle avoiding system result. Next. This is our final coding for our project. Next.
Okay, this is final coding of our project. So in the slide, we have the important input coding. As you can see, we have setting here stopwatch delay at 2000. Go back delay at 2000. Stop gain delay at 1000, and go left delay in bracket 1000, and finally is go straight if delay 1000. So and here we have we have to setting the parameter cm equal to duration time to 0.034 over 2. So here we will know the 2000 is the in cm. Okay, we go to the next figure. As you can see here, go wide straight. If the coding, if the robot have the parameter like this, as we can see, the digital right is LM1 high, digital LM2 low, RM1 high, RM2 low. It will go straight, and the LCD will show nothing ahead or and moving forward. Same to the it will go left if the LM1 low, LM2 low, RM1 high, RM2 low. It will go back if the LM2 high, LM1 low, RM2 high, RM1 low. And the LCD will pop out taking reverse, and it will go straight if the LM1 high, LM2 low, RM1 low, RM2 low, and it will pop up turning right. It will go, it will stop if the LM1 low, LM2 low, RM1 low, RM2 low. It will stop. And the last is it will stop and pop up something ahead and stop if the LM1 low, LM2 low, RM1 low, RM2 low, as we can see at this slide. So next is Muhammad. Next slide.
Okay, next slide is about circuit diagram. Obstacle avoiding robot was designed, construct and program which may use for our group assignment project. The developed robot will move in a particular direction once the ultrasonic sensor send a signal while avoiding the obstacle in path. The robot can also perform desired tasks in unstructured environments without continuous human guidance. The hardware was integrated in one application board as embedded system design. The software has developed using Tinkercad Altair software. Ultrasonic sensors have proven to have excellent detection capabilities over a wide range of distance, and they are often utilized in mobile robots to avoid collisions. To the obstruction in front of the sensor, the emitter sends a burst of ultrasonic inaudible noise. The item reflects the signal back to the sensor receiver, and when the sensor receives the echo, it generates an impulse. Next.
I will show you the result of our circuit design obstacle avoidance system. So I will share you the window. So here our circuit diagram, which is run in Tinkercad. We are using ultrasonic distance sensor since IR sensor are not compatible for this software. So we change the sensor. If then here the ultrasonic sensor function, if there is an object here, it will pop out at the LCD, such as taking reverse. So here the object, so it will reverse for us. So here the function. Thank you.
Okay, for the discussion, this project aims to understand how the ultrasonic sensor works. The sensor will have an important role in detecting obstacles. Sensors to avoid obstruction are installed on the robot that is HCSR04 ultrasonic sensor. The basic principle of this ultrasonic sensor is to record the time taken to transmit the ultrasonic beam and receive the ultrasonic beam after it hits the surface. The distance will be calculated using a formula. Okay, for the conclusion, an obstacle detection circuit was successfully implemented using ultrasonic sensor modulus. Placed at the front of the robot to throw the sound wave at any obstacle, and when a reflection is received, a low output is sent to the Arduino microcontroller, which interpret the output and make the robot to stop. The circuit is assisted by L298N dual H bridge motor driver that control the breakout board, typically used for controlling the speed and direction of motor. This will help the robot in controlling the speed and direction from colliding with any obstacle. Okay.
Okay, done. So that's all from our group, and I hope we will get the great result in our final result. Thank you, sir.